Today we're going to go over section 4.1, the first section in chapter 1, and this is over graphing quadratic equations. So we're going to learn how to find the vertex, how to find other 2 points to graph the parabola, and we're going to talk about different parts of the parabola that we haven't discussed before. Okay, so let's read through the notes and then we'll do some examples. A quadratic equation is in the form ax squared plus bx plus c equals 0. Ax squared is the quadratic term, bx is the linear term, and c is the constant. The graph of a quadratic equation is in the shape of a U and is called a parabola. The lowest point of the graph is called the vertex and represents the minimum point of the graph. If the U is upside down, the vertex will represent the maximum point of the graph. The y-coordinate of the vertex is the maximum or minimum value. The x-coordinate of the vertex tells where it occurs. If a is negative, if it's less than 0, the parabola will open down. If a is positive, if it's greater than 0, the parabola will open up. The coordinates of the vertex is found with the formula negative b over 2a and f of negative b over 2a. And we'll do an example like that in a second, so that'll make more sense. The parabola is symmetric to a vertical line that passes through the vertex. This line is called the axis of symmetry. The equation of the axis of symmetry is x equals negative b over 2a. The y-intercept of the graph is the point where the graph crosses the y-axis, 0 and whatever the constant is, c. The value of x is always 0 at the y-intercept. To graph a parabola, find the x-coordinate of the vertex and choose values on both sides to make a table. Okay, so let's go over all that information that we just read, organize it a little bit better so that you'll have a more comprehensive notes to look at while you're doing your assignment. Okay, so first of all, you have this quadratic equation that's in standard form. Ax squared plus bx plus c equals 0. And when it's in standard form, it does matter the order that it's in, and it does matter that it's equal to 0. Okay, so the quadratic, the squared term, needs to be first. The linear term, where you have x to the first power, needs to be your middle term, and then your constant is always last. Now this 0 is the same as your y. It replaces the y sometimes. So you might see this equation written like this, ax squared plus bx plus c equals y. Or if it's in function notation, it would look like ax squared plus bx plus c equals f of x. So your a, b, and c are numbers. Just right now it's a generic equation, so they have letters replacing the numbers. Okay, so the a is your quadratic coefficient. B is the linear coefficient, and C is the constant. And your numbers that are representing A, B, and C that you're going to have in a regular equation are what you substitute into the formulas we went over to find your vertex and your axis of symmetry. So let's go over those real quick. Your vertex the little formula for that is negative b over 2 times a. That will get your x-coordinate for the vertex. Okay, so this negative is part of the equation. It's always going to be there. Your b is whatever value the b is, and then a is whatever your a value is in the equation, the quadratic equation. And once you find your x-coordinate, you take that number value and plug it back up into your quadratic equation. And that gives you the y. So that's why they have f of negative b over 2a written in that way, because that's function notation, and that's just telling you to take that value for your x, plug it into the equation, and that will get you the y value. Okay. Okay, so after you find the vertex, that gives you the answers for everything else that you're going to be doing in this assignment. The vertex is a very important point. You got to make sure, first of all, that it's the correct point, so it wouldn't hurt if you double checked your work just to make sure that that's exactly what it's supposed to be. Okay, so from your vertex, the y coordinate gives you a max or min value. It's going to be a max value if it opens down and a min value if it opens up. The x-coordinate of your vertex tells you where the max or min occurs. So those are two distinct questions. The maximum or minimum value is how much there is or how little there is. The x-coordinate, where it happens on your graph, is like, okay, where is that maximum? Like, here's your graph. Where is that maximum going to be? It's where x is, whatever. Okay, so you might be wondering, how can you tell if the graph is going to open up or down? And that is determined by your A. If your A is a positive value, it's going to open up. It's positive, it's happy, it's smiley. If A is a negative value, that's negative. It's going to open down. It's going to make a frowny face because it's all negative. Okay, so the next thing is the axis of symmetry. So let's say we have this parabola over here, and the axis of symmetry is going to go right down the middle. It's going to intersect at the vertex point, and it's going to cut the parabola in half. So if you folded the parabola on that line, it would match up exactly on either side. And your axis of symmetry, which I usually abbreviate with AOS, is x equals negative b over 2a. Okay, so you do need to have that x equals part in your equation because this is a line. So that does matter. You will get points taken off if you don't have x equals, excuse me. So that negative b over 2a, I hope, looks a little familiar. It's from your vertex. So once you find the x-coordinate for the vertex, you know the formula or the equation for the axis of symmetry. So you don't have to recalculate anything. You can just use that x-coordinate and write x equals whatever that number is. That's going to be your equation for the axis of symmetry. Now for your parabola, the y-intercept is always 0, c. And c is whatever the constant is in your equation. So let's do an example here. Let's just say I have this quadratic equation. Okay? The y-intercept is where x equals 0. So that 0 is never going to change for your y-intercept. Now if I plug that in to this equation, do it the long way, that's going to make this 0, and this is going to be 0. All that's left is the constant. So they're giving you a little shortcut by saying the y-intercept is always going to be 0 and whatever the constant is. In this case, it'd be 0 and negative 1. All right, so let's do an example. Let's look at number 3. Let's work that one out. I'm going to change papers. Okay, so number 3, f of x equals x squared plus 9 minus 6x. First of all, before you start, you want to rearrange the equation so it's in the right order. Right now, it's out of order. So I want to have my squared term first, my linear term second, and the constant last. Okay, so I'm going to define A, B, and C. In this problem, A is going to be a positive 1. There's not a number written in front of the x squared, so it's understood to be a 1. B is negative 6, and C is 9. Okay, so the instructions are to find the direction of the opening, the coordinates of the vertex, the equation of the axis of symmetry, the y-intercept, the max or min value of the graph, and where the max or min occurs. And then they want us to graph it. So I'm going to find all of those information, all those parts first, and then we'll graph the problem. Okay, so for A, they want us to find the direction of the opening. Well, that's determined by the sign of your A value. The sign here is a positive 1, so it's going to open up. So from that, you know you're going to have a minimum value. Okay, so we'll save that for later. They don't need that yet. On part B, they want you to find the coordinates of the vertex. Okay, your vertex formula is negative b over 2a and f of negative b over 2a. Okay, so let's find the x-coordinate first. X equals negative, that's part of the equation. B is negative 6 over 2 times positive 1. So I have negative, negative, that's going to make that positive. Positive 6 divided by 2 is going to be 3. So my x value is a positive 3. To get y, I'm just going to substitute 3 in for the x's in my equation. So f of 3 equals 3 squared minus 6 times 3 plus 9. So I'm going to have 9 minus 18 plus 9. Okay, well this one's going to work out to be 0, it looks like, for y. So my vertex point is 3, 0. So that's your most important point on the graph. All your other answers that we're doing today are going to come from that vertex point. Okay, on part C, it's asking for the equation of the axis of symmetry. Well, the equation for the axis of symmetry is x equals negative b over 2a. And I already calculated that negative b over 2a right here, so I just need to write x equals 3. And that's my equation for the axis of symmetry. And yes, it has to have the x equals on it. Do not just write the number or you're going to get it wrong. Now part D, the y-intercept. The y-intercept is 0 and whatever the c is. So for number 3, since c is 9, my y-intercept is 0, 9. And on part E, they want the maximum or minimum value of the graph. I'm going to scoot this back down just for a second. So your value is the y-coordinate of your equation, of your vertex. Okay, and I set up here on part A, since it opens up, I'm going to have a minimum. So the y-coordinate for your vertex is 0. So that means the minimum, I'm just going to put min value is 0. And you don't have to write it out, you can just put the number 0. Okay, now the next part, F, where does that occur? So your x-coordinate of the vertex tells where that min value occurs. So the min occurs where x is 3. And you do need to make a distinction between the two. Don't just write numbers down, but label what they represent. So now I'm ready to graph. I'm going to make a table of values. The first table the first set of values I'm going to use is the vertex. You always want to start with the vertex. That's the most important point. Okay, so I'm going to draw my graph. And you guys need to use graph paper whenever you do this. So 3, 0 is right here on the x-axis. To get my other 2 points, I'm going to pick an x value on either side of the vertex, plug it into the equation, and get my y value. So For example, I could use 1. That's 2 units to the left of the vertex. So if I choose 1, 2 units to the left of the vertex, I want to choose a point 2 units to the right of the vertex, and that would make that 5. So 5 and 1 are my two x values I'm going to use. So let's plug those in and get the y values. Okay, I'm just going to do it out here to the side. So when x is 1, I'm going to have 1 squared minus 6 times 1 plus 9. So 1 minus 6 plus 9 is going to be 4. So that value is 4. I should get the same y value from my next x because they're the same distance away, but I'm going to calculate it just to make sure. So we got 25 minus 30 plus 9. And that equals 4. So 1, 4 right there, and 5, 4 right here. So your graph is going to look like this. I want to make sure I make it curve at the bottom because it's a parabola. Don't make it pointy like an absolute value graph. And that's it. Okay, so one more thing we're going to do before I sign off here. I want to find the domain and range. Okay, so your domain is your x values. Is there anything that x cannot be on this graph? And the answer is no. There's no restrictions for your x. So that's going to be all real numbers. Now your range, you can I'm sure you can already see that there is a restriction on the range. It's not going to go below 0 for y. Everything on the y has to be above 0. So we're going to use set builder notation, all values of y, so that y is greater than or equal to 0. And that's the end of that problem. Make sure and read the directions on your assignment because they don't have you doing everything that we just did on that one problem. You're going to do different things on different problems. So make sure and do that, and I'll see you tomorrow.